Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. And this is extended physics. The code of the subject is 0625. Today we have set our heart to solve paper 2 of this subject. The paper 2 of this subject is related with the multiple choice paper. Here we have 40 multiple choice questions, and the time allowed for this paper is 45 minutes. So let's start. The paper we have selected is October-November 2023 2-1 paper. This paper 2 belongs from the zone 1. In this video, I'm going to present you the solution of this paper to the best of my knowledge, to the best of my abilities. So let's start today's paper. So here we go. Okay, so on your screen, that paper is showing up. This is October-November 2023 2-1. This is physics, the standard physics of the Cambridge IGCSE 2-1 paper, 0625/21. The time allowed is 45 minutes. So here we go. The first question is showing up on your screen. Which is a vector quantity? Density is a scalar quantity. Mass is a scalar quantity. Pressure is a scalar quantity. Weight has direction. It is always towards the center of the earth, if we are talking about the weight on earth. So I think the D is the choice. I think the D is the best choice here. So I think the D is the answer. So let's check. D is the right answer, sir. Question number 2. The graph shows the speed of a car traveling through a town. Which section of the graph presents a period when the car is decelerating? On the speed time graph, the deceleration is represented with the negative gradient. Negative gradient means when the graph, as you move to the right, the graph is going downward. So on the speed time graph, that portion where the graph, when you move to the right, is going downward, that is the portion where the gradient is negative, and that represents the deceleration. So I think D is the choice here. I think D is the choice, sir. The answer is right. D is the right choice. Okay, so here we have question number 3. An object reaches terminal velocity. The object reaches terminal velocity after being dropped and falling through air. This word is very important. The air is there, so there is air resistance present. He says it was dropped and now it has reached the terminal velocity. So its speed will go on increasing, and then the speed will become constant. So, and because the air is present, so that line must not be a straight line. When its speed is increasing, the graph should be a curve because of the presence of the air. There will be acceleration there. I mean, non-uniform acceleration will be there. So if you look at these graphs, 4 graphs, okay, because in the start, the velocity will be 0, and then gradually the velocity will increase, and then the velocity will become constant. So A and C, they are in that competition because at the start, the velocity is 0, then the velocity is increasing, and then the velocity becomes constant. Here, the B is also in that competition. Okay. Now, if you look at this A graph, this gradient is constant. That happens when there is no air. So the choice can be B or it can be C. Now, if you look at the gradient of the B here, it is gradually increasing. That means the value of the acceleration is gradually increasing. But in the presence of air, when you fall down at the start, your acceleration is maximum. But because as the air resistance due to your increase in the speed increases, the value of your acceleration decreases. Your velocity is increasing, but the acceleration value is gradually decreasing. So the gradient of that graph must be gradually decreasing. And at the terminal velocity, the gradient becomes 0, means the graph becomes flat. So I think C is the best choice. It's an ideal question. And C is the choice. Question number 3, C is the right choice, sir. Question number 4 is showing up on your screen. He says the table shows the mass and volume of 3 different liquids, X, Y, and Z. Liquid X has mass 120 gram, volume 200 cubic centimeter. Y has 80 gram mass and 67 centimeter cube volume. The, the liquid Z has 100 gram mass and its volume is 120 centimeter cube. The liquids are placed in the same container. The liquids do not mix. Which liquid is at the top of the container and which liquid is at the bottom? You see, it's very simple. You will calculate the density of X, the density of the Y, and the density of the Z. So when you put 3 liquids, you put them in the same container, the liquid with the least density will be on the top, and then the liquid with the greatest or the largest density, that will be at the bottom. So let me show you, I have done this. Okay, so on your screen, this is showing for X, the density will be mass divided by volume. 120 divided by 200, that is 0.6 grams per centimeter cube. For Y, the density will be 80 gram divided by 67 centimeter cube, and it will be 1.19 gram per centimeter cube. And for Z, it will be 100 divided by 120, and that will be 0.83 grams per centimeter cube. So you can see here, this one has the lowest density, so it will be at the top, and this one has the highest density, so it will be at the bottom. Okay, on the top will be X, and then you will have Z, and then you will have Y. So on the top will be X, and on the bottom will be Y. On the top, you will have X, and the Y will be at the bottom. So I think A is the choice, sir. Question number 4. A looks the right choice. This is how I have found this, and this is that question. So A is the choice. Question number 5. Which moving object has a resultant force acting on it? A driver rising vertically through a constant speed. So because he is rising vertically through a what? At a constant speed. When you move at a constant speed and you move vertically, so the resultant force will be 0. An aircraft circling an airport on a constant at a constant speed. When you move in a circle, remember this, whenever you move in a circle, although your speed is constant, but still because you are moving in a circle, the direction of your motion is constantly changing. So that's why whenever you are moving in a circle, there is a resultant force acting on you, which is directed towards the center of that circle. So B has resultant force. A train going up a straight incline at a constant speed because it's moving at a constant speed and it's going in a straight line. So the resultant force is 0. A parachute is descending vertically at a terminal velocity. When you are falling down with the terminal velocity, the resultant force is 0. So in the B choice, we have resultant force. So question number 5, B is the right choice, sir. Then we have question number 6. Forces are applied to 4 identical objects. The length of each arrow indicates the magnitude of the force. Which object is in equilibrium? The object will be in equilibrium if the line of action of the opposite forces is same and they are equal in magnitude. So for example, if you look at here, they are balanced. These two forces are also equal to each other, but their line of action is not same. So what will happen? It will start rotating. Here, if you look at the B, upward force, downward force, they have the same length, they have the same line of action. So they will be cancelled with each other. These two are equal in length, opposite in direction, same line of action. So they will have an exact resultant force which will be 0. So they will cause, this body will be in the equilibrium. This body will, these two forces acting opposite to each other, their magnitude is same, okay, but their line of action is not same. So they will cause this body to rotate. So here the forces are not balanced, their magnitude is not same. So B object will be in the equilibrium. So B object will be in the equilibrium. The answer is right. Hopefully you understand. Question number 7. Okay, so we are solving IGCSE physics. It's October, November 2023 paper, and the number of the paper is 2-1. This is extended physics, and we are now going to attempt question number 7, which is an MCQ question. A sphere X collides head-on with a second identical sphere Y, which is stationary. Okay. The mass of each sphere is 0.15 kg. So here we have a Y, and here we have an X, and it is coming, it's moving, it's not moving, it's stationary. The Y is stationary, the X is moving, and sphere X is traveling at a speed velocity of 2 meters per second before the collision, and produces an impulse of 0.21 Newton second on the sphere Y. So what happens? It collides with, the X is moving, it collides with the Y. So they both have the same mass, 0.15 kg. This is 0.15 kg, this is also. So they collide, and obviously what will happen? They will move in the same direction. Maybe in the same direction, maybe not in the same direction. But when they will collide, the Y will also start moving. So before the collision, the momentum of the system, and after the collision, the momentum of the system will be same. So he says sphere X is traveling at a velocity of 2 meters per second before the collision and produces an impulse. This sentence is very important. And produces an impulse of 0.21 Newton second on the sphere Y. You know, impulse is equals to the change of momentum. So they are talking about the sphere Y, the second sphere, which was stationary. So the change in the momentum, which is called impulse, is equal to 0.21 Newton second. That is for the sphere Y. So I know that the initial velocity of the Y was 0. Its mass is 0.15 kg. So after the collision, its mass will be obviously still 0.15 kg. But what will be its velocity? We can calculate. And once I know the velocity of the sphere Y after the collision, I will be able to tell what is the velocity of the X after the collision. What is the velocity of the sphere X after the collision? It's a little heavy question. What is the velocity of the sphere X after the collision? It's a kind of a question, a little heavy question. Okay, so for Y, it is given that the impulse is 0.21 Newton a second. So for Y, the impulse is change in the momentum. So for Y, let's say I'm calling it M2, and its velocity after the collision is V2. Its velocity before the collision is U2, and that was 0. The velocity, initial velocity of the Y was 0. So the change in this momentum is equal to 0.21 impulse. Okay, so 0.15 multiply V2 minus 0.15 multiply 0 is equal to 0.21. So you will have 0.15 V2 equals to 0.21. So V2 will be 0.21 divided by 0.15, and the V2 will be 1.4 meter per second. Now, this is the velocity of the Y after the collision. Now, for X and Y, means that's the system. The momentum before the collision and momentum after the collision of the system will remain same. Okay, so momentum before the collision is m1 u1 plus m2 u2. And momentum after the collision will be m1 v1 plus m2 v2. V1 means the velocity of the X after the collision is question. So M1 is 0.152, U1 is 2, plus M2 is 0.15 kg, and the U2 is 0. Y was stationary. After the collision, the 0.15, M1 is 0.15, Y1 is the velocity of the X after the collision. We don't know that. We want to find out that. Plus M2, V2, that is 0.15 multiply 1.4. That's the velocity of the Y after the collision, 1.4 meter per second. Now, we will have 0.3 equals to 0.15 V1 plus 0.21. So 0.15 V1 will be equal to 0.3 minus 0.21. So 0.15, I'm here. 0.15 V1 equal to 0.09. V1 will be equal to 0.09 divided by 0.15. So V1 will be equal to 0.6 meter per second. So because it's positive, the answer is positive. And we have taken the initial velocity of the X also as positive. So that means it's going in the same direction. So 0.6 meter per second going in the same direction. 0. The Y velocity was also positive, you know. So the Y is also going to the, suppose, to the right. This is also going to the right. Okay. So 0.6 meter per second in the same direction as the Y. So I think B is the answer, sir. Question number 7, B is the answer. So this question is, the answer is B. You can see there, B. This is how this is done. So let me show you this. So this is the solution of that question number 7, a very tricky question, not an easy question. I hope you understand. So this was a question on momentum. Okay, so we are going to the next question. The next question coming up on your screen is question number 8. A cyclist travels down a hill from rest at the point X without pedaling. The cyclist applies his brakes and the cycle stops at the point Y. Which energy transfers have taken place between X and Y? Because he is coming down without paddling, that means whatever was his gravitational, he's coming down the slope due to his gravitational potential energy. So the gravitational potential energy is converting into kinetic energy. And when he applies brakes, the kinetic energy converts into the heat, thermal energy. So internal thermal energy. So I think A is the right choice. Question number 8, A looks the right choice, sir. And that is the right choice. When he's on X, he has gravitational energy. When he's coming down without paddling, his gravitational potential energy is converting into the kinetic energy. And when he applies brakes, that kinetic energy converts into thermal energy. So A is the choice, sir. Question number 9, he says, an object of mass M falls from a higher shelf to a lower shelf. So it is falling from here to here. So here the kinetic energy will be mgh1. So here it is mgh1. When he reaches here, the kinetic energy, the gravitational, I said kinetic, is gravitational potential energy will be mgh2. So the difference between them will be, if you take the mg common, it will be mg bracket h1 minus h2. How much gravitational potential energy does the object lose? Gravitational potential energy here minus the gravitational potential energy here at this lower point. So it will be mg bracket h1 minus h2. So question number 9, D is the choice, sir. That is the right answer. So I hope you understand this. Question number 10. A pump does 460,000 joule of work to raise the water to fill a tank. It takes 7 minutes to fill the tank. What is the power of that pump? And the answers are in kilowatt. So this is question number 10. And let me show you. Okay, now the power is equals to the work divided by time. So work done here is 460,000 joules and the time taken is 7 minutes, but the time should be taken in seconds. So that's why I will multiply 7 with the 60. So you will have 460,000 divided by 7 divided by 60. So you will get 109.24 watt. But the answers are in kilowatts, so I will divide both the sides with the 1000. to convert the watts into kilowatts. So you will have 1.09524 kilowatt, which is, when you round it off, it is 1.1 kilowatt. So 1.1 kilowatt is a choice. So I think question number 10, A is the choice. The answer is right, sir. So now we are going to the next question. That is question number 11. The water in a swimming pool exerts a pressure at the bottom of the pool. Which graph shows the relationship between the pressure exerted by the water? So they are talking about the pressure exerted by the water and the depth of the water in the pool. You know, the pressure, the formula for the pressure, if you remember, the formula of the pressure due to the liquid is rho, G, and H. So it is directly proportional to the H, which is the depth of the liquid above the point of the observation. More the depth of the liquid above the point of observation, the more will be the pressure due to that liquid. So if the depth of the liquid becomes zero, the pressure will also become zero. So the relationship between the pressure and the depth of the liquid is directly proportional. So the relationship is a directly proportional relationship. So it should be C. This word is very important. You see, even if the depth of the water above the point of observation becomes zero, still the atmospheric pressure is acting on the body. So, but here they are talking about the pressure due to the water. So that's why the pressure, when your depth of the water above you becomes zero, the pressure due to the water on you becomes zero, although the atmospheric pressure is acting on you. But they are talking about the pressure due to the water. So this word is very important. They can be tricky. So I think C is the choice, sir. C is the choice. Let me show you the whole question. I think question 11, C is the right choice. Question number 11, C is the right choice. Okay, so here we have question number 12. He says, why can a gas be compressed easily into a smaller volume? You see, normally when this question comes in theory paper, we say the force of repulsion between the particles of the gas is less. That's why you can bring them closer to each other. But here, that option is not given here. A option is the particles are far apart. Yes, this is one reason. And he says the particles do not attract each other. That's not right. The particles move not randomly. That is right, but this has nothing to do with the compression. The volume of each particle can be reduced. You cannot decrease the volume of the particles. You can decrease the distance between them. The particles are far apart. That's why you can bring them together. Question number 12, I think A is the choice. My answer is right, sir. Okay, here we have question number 13. A gas is contained in a cylinder by a movable piston. The gas is heated so that it expands at constant pressure. How is the force of each collision of gas particles with the piston affected, and how does the frequency of collision between the gas particles and the piston changes? So because the pressure is constant, the volume is changing here. So when you will increase the temperature, what will happen? The kinetic energy of the particles will increase. So now they are going to hit the gas container with a larger force, obviously. But still, at the end, what will happen? The pressure of the gas will remain constant. That is the rule. That's the gas law. Because the volume is changing, you are increasing the temperature, the volume will increase. But he says that the pressure remains constant. But you know, when you increase the temperature, so obviously the particles will start moving faster, their kinetic energy will increase. So when they will hit the walls of the container, they will exert larger force. But how come this is possible that still the pressure is same? Because their collision frequency with the walls of the container will decrease. So it's a very tricky question. The force exerted by the particles will increase and the frequency of their collision with the walls of the container will decrease. So I think A is the choice. This is, I think, question 13, A is the right choice. It's a very, very tricky question. Okay, question number 14 we have on our screen. He says, on a warm day, a carton of fresh milk is covered with a wet cloth. Why does this help to reduce the temperature of the milk? You see, why we do this? When you cover some container with a wet cloth, so what will happen? The water from that cloth will evaporate, and the remaining water in the cloth, its temperature will drop, because the more energetic molecules or particles of the water have gone into air. So the remaining particles, they have less kinetic energy, so the average kinetic energy will drop, and the temperature of that thing will drop. So some water evaporates from the cloth, so the remaining water becomes colder. That is a right choice, sir. The water has a very high specific heat capacity. The water insulates the milk from the warm air around it. The water is always colder than air around it. That all is nonsense. Question number 14A is the right choice, sir. Question number 15. A chef heats some water in a pan on a hot plate. The temperature of the water rises by 10 degrees centigrade in the time t. She then puts the same volume of oil in an identical pan on the same hot plate. The specific heat capacity of the water is 2.5 times that of the oil. So they are talking about the specific heat capacity of water. The water is 1.5 times denser than oil. What is the time for the temperature of the oil to rise by 10 degrees centigrade? Okay, so this is question number 15 from the IGCSE physics, the standard physics, and this is October, November 2023, 2-1 paper. It's a multiple choice paper, and it's question number 15. It's a very tricky question on the topic of heat. So she puts the same volume of the oil. So the volume of oil and the water is same. So water, to raise the 10 degree centigrade temperature of the water, the time taken is T by that hot plate. Very tricky question. How much time the oil will take to raise this much temperature? So for oil, suppose the heat required is mc delta theta. So suppose the mass of the oil is density of the oil multiply the volume of the oil. So here we have density 1 multiply volume 1. I'm talking about oil, and its specific heat capacity, I'm calling it C1, and delta theta is change in temperature, that is 10. So the heat required by the oil to raise its temperature through 10 degrees centigrade will be 10 multiply the density of the oil, multiply the volume of the oil, multiply the specific heat capacity of the oil. Now for water, heat required to raise the temperature of the water will be mc delta theta, same formula. The mass of the water will be volume multiply density. The water volume is same volume as that of the oil. The density of the water is 1.1 times than the density of the oil. So the density of the water will be 1.1 density 1. And the specific heat capacity of the water is 2.5 times more. So it will be 2.5 C1. And the change in the temperature of the water is also 10 degrees. So when you multiply 1.1 with the 2.5 with the 10, you get 27.5. And density 1 multiply volume 1 multiply specific heat capacity 1, which is for the oil. Okay. Now he says the power, the power is equals to the heat divided by the time. Now the water takes T seconds to do this. So the heat required for the water was 27.5. Rho 1, volume 1, capacity 1, specific heat capacity 1. So divided by time. T. It was given T. Now because it's the same hot plate, so it has the same power. For the oil, the power will be equals to heat 1 divided by the time 1. And the power we have already calculated for that hot plate. So I will put this to 27.5 rho 1 V1 C1 divided by the T that was given in the question equals to. Now for the oil, it is 10 rho 1 V1 C1 divided by the time 1. I want to calculate this time. So this row and this row will be cancelled, volume and the volume will be cancelled, then this and this will be cancelled, and and you are left with, so this time 1 will be equals to T multiplied 10 divided by 27.3, and that time will be 0.3, 0.36 T. 0.360, 0.360. The choice is A. Let's check. This is question number 15. Question number 15A is the right choice, sir. 0.36T. Let me show you the solution again. I am going to reduce the size so you can see the whole answer together. Okay. So now on your screen, the answer of the question number 15, how I did this is showing up. It's a very, very tricky question. Not an easy one. Okay. So hopefully you understand. Okay, now we are on the question number 16, and this is the diagram shows the view of a room heated by a radiator. The arrowed line from X to Y is the path of the convection current in the air. So here, radiator, this is a heater. Here, the air becomes hot, becomes less dense, it rises upward. The cold air is going downward, it's more denser, it's colder, its temperature is less. Here the temperature is higher, here the temperature is less, here the density is low, here the density is high. Their question is which row? Their question is that, okay, which row about the air temperature and the air density at the X and the Y is correct? The temperature at the X is higher and the density at the Y is higher. Okay, so I think B is the right choice. And the temperature at the X will be higher, and here the density will be higher. So B is the choice. Question number 16, B is the right choice, sir. Now we have the next question, that is question number 17. He says two men, P and Q, stand close to a gap in a wall as shown. Man P cannot see man Q, but P can hear man Q speaking. Which statement explain this? The P cannot see Q, but he can hear his voice. The reason is the sound waves can, what we call it, diffract here, and they can bend here, and they can go to the P, but the light waves coming from the Q do not diffract that much. So they diffract, but not that much that they can go to P. So the sound waves can diffract here and they bend a lot, and that's why he can hear the sound coming from the Q. But the light waves do not diffract that much. So he says light waves do not diffract at all. This is wrong. They diffract, but not that much. Light waves have a range of frequencies, but sound has just one frequency. That is wrong. Sound has a lot of frequencies. Sound waves are of a higher frequency than the light waves. This bending does not depend upon the frequency. The sound waves diffract a lot, that is right, because their wavelength is a smaller size to the width of the gap. Okay, so that is most probably the reason. The sound waves diffract a lot because their wavelength is, as I said, smaller. It is the word similar size as to the width of the, and that is the rule. If the wavelength of that wave and that gap is same, circular waves, semicircular waves, wavefronts are produced. So I think D is the best statement. D, question number 17, I think D is the right choice, sir. Now we are going to the next question, which is question number 18. And he says, which quantities relating to a wave on the surface, which quantities relating to a wave on the surface of water can both be measured in meters? Amplitude, obviously, that can be measured in meters, and the wavelength can be measured in meters. Frequency is measured in hertz, and the wave speed is meter per second. Okay, so the two quantities which can both be measured in meters is amplitude and the wavelength. Question number 18B is the right choice. Question number 19. So here we have question number 19. It says the diagram shows the part of a ray diagram. that demonstrate the formation of a virtual image Y of the object X by a converging lens. One ray of the light from X is shown approaching the lens. Which arrow shows the direction of this ray as it leaves the lens? Okay, so this is that case in which the object is placed inside the focal length of a convex lens. This is the case when the convex lens is acting like a magnifying glass. So when the object is inside the focal length, the lens makes a virtual and magnified and erect image of the image. So this ray which comes parallel to the principal axis, after passing through the lens, it passes through the F here. But how do I know? I can join it with this, and you can see, I will try. Okay, so this line which I am making continuous, this line must be dotted, but I made it continuous. So this, you see, this line is supposed to be, dotted. So let me try to make it dotted. So to be correct. Okay, because this is not a real line. So this seems that it is coming from here, but the actual light is. So their question is here. You can see he says one ray of the light from X is shown approaching the lens. Which row shows the direction of this ray as it leaves the lens? So this is that ray. So where is that? So I think A is the right choice, sir. A is the right choice. Okay. So I think A is the choice. Question number 19. A is the right choice, sir. Okay, so here we have question number 20. A ray of light is reflected by a plane mirror. Which row shows the angle of incidence? This is the angle of incidence, and this is the angle of reflection. Okay, angle of incidence is the angle between the normal and the incident ray. Angle of reflection is the angle between the reflected ray and the normal. So the Q and the R. Angle of incidence is Q and angle of reflection is R. So I think C is the choice. Question number 20, C is the right choice, sir. Question number 21. A thin converging lens is used to produce a real image of an object. Which statement about the real image is always correct? Whenever the convex lens makes a converging lens makes a real image, the image and the object, they are opposite on the opposite sides of the lens. Okay. So if the object is on the right side of the lens, the image will be on the left side. If the object is on the left side, then the image will be on the left side. Okay. So the image and the object are always opposite on the opposite sides of the lens. It is near to the lens than the object. It is on the opposite side of the lens to the object. Yes, that is true. It is the same size as that is not the size. Sometimes the image is small, diminished. Sometimes the image is magnified. Sometimes the image is of the same size. It is upright. That's wrong. The real image is always inverted. So I think question number 21, B is the choice, sir. That is right answer. Then we have question number 22. He says, a radio transmitter broadcasts a frequency of 200 kHz, 200,000 hertz. I mean, what is the wavelength of this radio wave? You know, V is equals to F lambda because it's an electromagnetic wave. So its speed is 3 expo 8 meter per second. So we will use that. Okay. So, you know, V is equals to F lambda. The velocity of the electromagnetic wave is 3 expo 8 meter per second. The frequency is 200,000 hertz. And the lambda, it means the wavelength is the question. So the lambda will be equals to, in your calculator, you will write 3 expo 8 meter per second divided by 200,000 hertz. So your answer will be 1500 meter, which is 1.3 expo 3 meter. 1.3 expo 3 meters. So I think C is the choice. And question number 22, C is the right choice, sir. This is my solution, and this is how this is done. Question number 23. The element mercury exists as a solid, a liquid, or a gas. Which row gives a possible set of values of speed of the sound through mercury? So when it is solid, the speed of the sound will be largest, highest. And when the mercury is in gas form, the speed of the sound will be lowest. So in the frozen state, the speed must be highest and it should be slowest in the gaseous state. So I think D is the choice. I do not remember these numbers, but I know one fact that when the medium will be solid, the speed of the sound will be maximum. And when the medium will be liquid, it will be medium. And when the medium is gas, the speed will be lowest. That's the property of the sound wave. So D is the choice. Question number 23, D is the choice. Question number 24. Which metal could be used for a permanent magnet and which metal could be used uh, for the core of an electromagnet? To make the permanent magnets, we use steel. To make the core of an electromagnet, we always use iron, soft iron, because it's a soft magnetic material which can as easily be demagnetized. For permanent magnets, use steel, and for the core of the electromagnet, use iron. So D is the choice. Question number 24, D is the right choice, sir. Question number 25. Which statement, he says, which statement describes the direction of an electric field at a point? The direction of the electric field, we know wherever you want to find out the direction of the electric field, the standard procedure is you put a positive charge there, and in whatever direction the positive charge moves, that is the direction of the electric field at that point. So you put a positive charge there, in whatever direction the positive charge moves, that is the direction of the electric field at that point. So the direction of the force on a positive charge. C is the choice. Question number 25, sir. C is the right choice. Question number 26. Which statement about a voltmeter is correct? You see, the voltmeter, we always connect the voltmeter parallel to the appliance, and it measures the potential difference across that appliance. So it has a scale which is marked in ampere. That's wrong. It must be connected in series in a circuit. That is wrong. It measures potential difference. Yeah, it measures the potential difference. It must have three terms. That's wrong. So I think question number 26, C is the choice. Question number 26, C is the choice. Okay. A wire has a resistance, 8 ohm. A second wire has of the same material has twice the length and twice the cross-sectional area. What is the resistance of the second wire? You see, because both the wires are made of the same material, so both of them, their resistivity is same. Resistivity of the first and the resistivity of the second wire, that are same because they are made of the same material. So row 1 and row 2, resistivity 1 and resistivity 2 is equal. So because they are of the same material, so their resistivity is same. Now the resistivity is resistance multiplied cross-sectional area divided by the length. Now the R1 A1 by L1 is equals to R2 A2 divided by the L2. So 8 multiply area divided by length equals to R2. The cross-sectional area is double, 2A, and the length is also double, 2L. So this A and this A will be cancelled. This L and this L will be cancelled. So R2 will be equals to this 2 and this 2 will be cancelled. So you are left with 8 ohm. So the R2 will be also how much? 8 ohm. Question number 27, B is the choice, sir. Question number 27, B is the right choice. Question number 28. A plastic rod is rubbed with the cloth. The rod becomes positively charged. If something becomes positively charged after rubbing, that means it has lost electrons. The other thing will become negative. it has gained electrons because of the movement of the charged particles. Which row gives the name of these charged particles and the direction in which they move? So those charged particles are electrons because electrons are given, they are received. Okay. And the direction of movement, because the rod has become positive, that means they have gone from the rod to the cloth. So I think B is the choice. Question number 28. B is the right choice, sir. So here we have question number 29, a very interesting question. An alternating supply is connected to a diode and a resistor in series. So here we have our diode, and here we have alternating power supply, and here we have a resistor. Which graph shows how the potential difference across the resistor varies with the type T? So this is the graph for the alternating current supply. But because here we have a diode, so when the current will flow in this direction, it will let the current flow through it. But when the current will go in this direction, because this is alternating current, its direction is changing, its magnitude is continuously changing. So when the current tries to flow in this direction, the diode will become backward biased and it will not let the current flow through it. That's the property of the diodes. So in the half cycle of this, there will be voltage here, and in this half cycle, there will be no voltage. So the choice can be, so the graph for this voltage here on this would be either this or this. Now, I think it's C choice. Why? Because this is alternating current, its magnitude increases, decreases, increases. So that graph should be like this, and then there should be no voltage. Then the graph should be like this, and then there should be no voltage. So C is the choice. Question number 29. So we think question number 29C is the right choice, sir. I hope you understand. It's a little bit tricky question. Now we have question number 23. The diagram shows a circle used to switch on a heater when the temperature drops below a certain value. So when the temperature drops, this coil should become magnetized, and then this should close, and what should happen? This heater should start working. So how here the voltage can be increased on the drop of a temperature? Here we should have a fixed resistor, and here we should have a thermistor. Okay, thermistor. So I think B is the choice. So when the temperature will drop, the voltage here, the resistance will increase if thermistor is here. The voltage drop here will increase, so this will become a strong magnet, and this switch will close. This is it's a relay. Okay, so this heater will be switched on. So I think B is the choice. It's a little tricky question. B, question number 30, B is the right choice, sir. It's a very tricky question. Now we are on question number 31. He says a current in a solenoid produces a uniform magnetic field inside a solenoid. The magnetic field direction is due west. Okay. Which changes will produce a stronger magnetic field? So we want a stronger magnetic field with a direction due west. So you want direction to change, a 180-degree change. Okay. So use a smaller current? No. You want a stronger magnetic field, so you cannot use a smaller current. Use a larger current, yes. And turn the solenoid through 90 degree. No. We want a 180-degree change. Use a larger current and reverse the current. Yes, this is the choice. If you will use larger current, obviously a larger magnetic field will produce. But if you will reverse the direction of the current, the poles of the magnet will also change. If its magnetic field was towards east, then it will become to the west. So I think D is the choice. Question number 31, D is the choice. I hope you understand. Now we are on the question number 32. A metal rod PQ rests on two horizontal metal wires that are attached to a battery. The rod lies between the poles of a magnet. Okay. When the switch is closed, the rod moves to the right. So this is moving to the right. Okay. What could be changed so that the rod moves to the left? Uh, you can uh, you can change these poles, then it will go to the left, or you can change the direction of this current. How? You could reverse this battery. So he says, what could be changed so that the rod moves to the left? Open the switch? No. Reverse the battery terminals and exchange the poles of the magnet? No. Don't do these two things together. You have to either reverse the battery or keep the battery same, reverse the polarity of those permanent magnets. Reverse the battery terminal, but without exchanging the poles of the magnet. Yeah, this can be the answer. Turn the metal rod around P and Q. It does not change anything. So C is the choice, sir. Question number, this was which question? Question number 32. Question number 32, C is the right choice, sir. So let me reduce the size so you can see the whole question. It's a very tricky one. Okay, so we are on the question number 33. He says, a transformer in a computer is used to transform the main voltage of 240 volt to 12 volt. So it's a step down transformer. The number of the turns on the secondary coil is 2000. Which statement about the transformer is correct? It's a step down transformer. And how many number of turns are on the primary coil? That's the question. Okay, so let's see. Here you can see that this is a famous equation. The voltage on the secondary divided by the voltage in the primary is equal to the number of the turns on the secondary divided by the number of the turns in the primary. So voltage in the secondary is 12. The voltage in the primary is 240 volt. Number of turns in the secondary are 2000. The number of turns in the primary is question. The number of turns in the primary will be 2000 multiplied 240 divided by 12, and that will be 40,000 turns. And it's a step down transformer. 40,000 turns in the primary coil, and it's a step down transformer. So question number 33B is the choice. The question number 33B is the right choice. Question number 34. In alpha particles scattering, alpha particles are incident on a thin metal foil. Which row describe results from the experiment and a conclusion that the results lead to? So they are talking about the alpha particle scattering experiment, which is, we call it the Geiger and Marson scattering experiment, in which they discovered the nucleus. What they found was that most of the alpha particles go straight without deflection through the gold foil. So most of the alpha particles go straight as if there is nothing in their path. So very few of them deflects at a larger angle. So the conclusion was that most of the atom is empty space, and a nucleus is there, which is very small as compared to the size of the atom. Most of the alpha particles pass straight through the foil. Most of the atoms is empty space. A is the choice. Question number 34, sir. A is the choice. Question number 35. Alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei when they decay. Which emission can be deflected by an electric field? Alpha particles are positive, while the beta particles are electrons, so they are negative. And the gamma rays, they are neutral. They are not deflected by the electric field. So only the alpha particles and the beta particles can be deflected by an electric field. So question number 35B is the right choice, sir. Okay, we are going to the next question. That is question number 36, and it's a very, very tricky question. Question number 36 is from the paper. This is IGCSE Physics, Extended Physics, and we are doing it's October-November 2023 2-1 paper, which is an MCQ paper, and it's question number 36, which is related with the half-life. He says question number 36 is radioisotope X decays to the stable isotope Y. The graph shows how the mass of the Y present in the sample varies with the time. Okay, so Y here is our daughter nucleus. This is after the decay, this is formed. And obviously in the start, its mass is 0, and then gradually its mass increases. So that means in the after at this time, you see, after this time, the mass of the y is not changing. That means the decay process has stopped. After this, the mass of the y is no more increasing. So that means the decay process has completed, and now the value of the y is not increasing. So that means that at the start, the value of the x was this much. Okay. So the time duration in which the m has become half. Okay. That is the and that is and the half life of that x. So the for x, the graph is coming like this. Okay. This is for x. This is for y. This is the parent nucleus. This is the daughter nucleus. So if the x was m and the time duration in which the m becomes m by 2 for x, that is the half-life. So which time travel gives the half-life of the x? 0 to t2. So I think C is the choice. It's a very tricky question. C is the choice. Question number 36. C is the choice. Our answer is right. It's a very tricky question. Question number 37. Which particle is absorbed by a nucleus to cause nuclear fission? For the nuclear fission, a neutron is bombarded on a nucleus, and that nucleus breaks. That nucleus breaks into two smaller or three smaller nuclei. So a neutron, yes, a neutron is bombarded. Question number 37. A is the choice, sir. It's a famous fact. Question number 38. It is summer in the northern hemisphere of the Earth in June. Which statement explains why? You see, this northern hemisphere, it tilts as the Earth is orbiting around the sun. It tilts around its axis. The Earth tilts around its axis. So the Earth has tilted, and its northern hemisphere is now facing at an angle towards the sun. That's why there is summer. So the north pole of the axis of the Earth's rotation is tilted towards the sun in June. This is the choice. Question number 38. D is the right choice, sir. Then we have question number 39. It says, which statement about the sun is correct? The sun is a medium-sized star, and the main fuel in the sun is hydrogen and helium. So C is the right choice, sir. Question number 39. C is the choice. C is the right choice, sir. And it's a fact you should know this about the sun. Okay, then we have question number 40. And we do not know about these stars, but we can answer this. The table lists some information about some stars. Which star will eventually explode as supernova? So the star which is now red supergiant is the next stage in the life of that star will be supernova. Very simple. So whichever they have given you 4 stars there. Aldebaran, it's a red giant. Temperature is 3700 degree. And Betelgeuse, and that is red supergiant. Yes, this is the right stage. After this stage, after this stage of the life of the star, then the supernova will come. So I think that Betel, Betelgeuse, Betelgeuse, its pronunciation is Betelgeuse, is the right choice. Then we have Jeminga. Jeminga is a neutron star. That's the end of the. And D is the series, and that's a white dwarf. No, you see how we choose the right one. Yeah? But Beetle Jazz, how we choose it? Because it is a red supergiant. So after the red supergiant, supernova will happen. So I know B is the choice. Question number 40. B is the choice, sir. So we are done with this paper. There were 40 questions. And so today, my dear students, in this video, we have given you the solution of this IGCSE physics extended physics, whose code is 0625. We have solved its paper 2, and this paper 2 was from the zone 1. It was October November 2023 to 1 paper. We have provided you the solution of this paper to the best of our abilities, to the best of our knowledge. If I have made any mistake, just forgive it. And you can see it is very hot in Pakistan right now. So humid and hot, but we are here to provide MCQ questions for our O-levels students because their paper 1 is coming in June. So if you think that this video is useful and if you think that this video is helpful, please like this video, subscribe to my channel, share the link of this video with your friends, with your class fellows, with your teachers, with your junior students, and share the link of this video on your TikTok, on your Instagram, on your Facebook, on your Snapchat, whatever media you are using. Please share the link of this video there. When you do this, actually what happens, you help me to promote my channel and I am able to continue this work. This encourages me then. So thank you very much for watching this video and preparing the physics through my channel. It's a great blessing for me. The main aim of these videos are to make the life of students around the globe easier, their parents' life easier, their teachers' life a little easier. Thank you very much. Have a good day. God bless you all.